Let's take a look at question 5. Well, in question 5, we have the following case. It says, solve the differential equation, which is given to us as the second derivative of y plus y equals to cosine squared of x. Well, let us begin. What do we need? We need to find the auxiliary equation. M squared plus 1 is equal to 0. M is plus minus I. Well, as you can see, your complementary solution y sub c is equal to c1 e to power 0 cosine 1x. So you don't need to write down e to power 0. We get cosine 1x plus c2 sine x. From y1 and y2, we can find the particular solution. But first, we need to find the Wronskian of y1 and y2, which is equal to, well, here we have the cosine x, its derivative, negative sine x and sine x, and its derivative, which is cosine x. So the Wronskian becomes, as you can see, cosine squared plus sine squared, which is nothing but 1. Now, the particular solution can be written as u1 y1 plus u2 y2. To find u1 and u2, we're going to find the Wronskian as follows. So u1 becomes the integral of w1 over w, and w1 is equal to the determinant of 0, f of x, which is cosine squared. And on the second row, you have y2 and the derivative of y2. Now, for u1, we're using y2. To find u2, you have the integral of w2 over the general Wronskian, and w2 is equal to, well, here you're going to use y1 and the derivative of y1 and 0 and f. Step by step, we find each one of these, and we find u1 and u2. Let us start by finding u1. To find u1, we need w1, which is the determinant of 0 and f of x, which is cosine squared of x. y2 is sine x, and its derivative, which is cosine x. As you can see, this determinant is 0 minus sine x cosine squared of x. Now to find u1 is equal to the integral negative sine x cosine squared of x divided by the Wronskian, which is 1 dx. For using substitution, you can easily solve this. U is cosine x and du is minus sine x dx. So we have u squared. u1 becomes a third u cubed, or cosine to the third of x. This is u1. Now for u2 is the integral of w2. So we need to find w2. So let's write down w2 first. We have the determinant y1, which is cosine x, its derivative minus sine 0 and cosine to the second of x, which is cosine to the third of x minus the 0. So u2 becomes the integral of cosine cubed of x divided by 1 dx. We need to find the cosine to the third integral. We can divide this up and write it as cosine times cosine squared, cosine x times cosine squared of x dx. This guy can be written as the integral of cosine x, and cosine squared can be written as 1 minus sine squared of x dx. Again, you can use u sub. Using u sub, u is going to be your sine, and du becomes cosine x dx. So u2 becomes the integral of 1 minus u squared du, which is u, or just sine x, minus a third, and here you have u to the third, which is sine cube of x. So yp becomes u1, y1. You get a third cosine to the fourth plus u2, y2 sine squared of x minus a third sine to the fourth of x. Of course, we can simplify this more by writing a third and then write this guy as yp equals to a third cosine squared of x plus sine squared of x times cosine squared of x minus sine squared of x plus sine squared of x. So of course, this is just 1, and you end up with a third cosine squared of x minus sine squared of x, or cosine 2x plus sine squared of x. You can simplify this more, and eventually, when the question says, hey, find the general solution for this differential equation, it's going to be yc plus yp after simplifying the whole thing.